Hello and welcome to another ramble with me. And today we are rambling about IEB May 2025 paper 1, question 8. Those of you who've been with the channel, who've watched a couple of videos will know that I'm not a fan of finance. But I did recently learn how to use the future value and present value formulae, which is something that I've avoided doing since I was in high school. I've always approached finance using the geometric series formula. um, yeah, for some reason I was always petrified of learning how the finance formulae work. But I recently had to learn how they work, and I was like, oh my goodness, I've been missing out on the good times of life. And so now I am here to put my knowledge of those formulae to the test to really see, like, am I fully comfortable using them? Anyway, so let's give it a try and see. Sunette would like to invest in her grandson's future. Good on you, Sunette. Sunette has the goal of generating 200,000 Rand at the end of 16 years. She would like to start by depositing a certain amount of money at the start of the investment and then depositing half that amount 8 years later. The bank offers 11% interest per annum compounded quarterly. How much would Sunette need to deposit at the start of the investment? So this deposit is an X, right? And then she needs to deposit half that X 8 years later. So timeline wise, we have at T0 she wants to put in a certain amount X, and then 8 years later she wants to put in half of that X, and then at T16 she wants to have 200,000 Rand. Right, and all this while the investment is growing at 11% per annum, compounded quarterly. Right, so we can look at each of these as separate investments. So we want the X times, 1 plus 0,11 over 4, and that would grow for 16 years at that rate. And then the half X would grow at this rate for 8 years, sorry. And we need that to add up to 200,000. Right, so to solve this, we can factor out the common X, and then what will be left in each term is just numbers, right? So it's going to be this guy. Okay, that's what's left of the first term. And in the second term, we're left with the half times this guy. Oh. Why do you not do what I want? Technology. So it'll just be the half times that left, right? And big and nasty as this looks, this is just all numbers, meaning I can punch this into the calculator. So I'm going to have X times some number is equal to this. So if I divide both sides by this number, then I'm just left with X. So we have X times, I'm going to put this in, so it's X times 6,86 blah 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 is equal to 200,000. So then I divide both sides by that. So 200. Oh, okay. 200,000 divided by my answer. So that is going to be 29,124 and 20 cents is how much she would need to deposit here, and then half of that amount over here, and then at the end of the 16 years she will have 200,000 rand, which is incredible. So about 30,000 here, and then 15,000 here, and then at the end of the 16 years you have 200,000 rand. That's amazing. Investment for the win. Right, next up it says Sunette also starts an annuity. So this is an investment where she's going to be making a recurring deposit, say monthly. When she opens the account, she immediately pays 800 rand and then continues to make payments of 800 rand at the end of each month. The investment contract is for 16 years and the bank offers 9% interest per annum compounded monthly. So that's good. We know that for our future value formula, the regularity of the payments, so how often she's making payments, should match how often interest is being calculated. Otherwise, we would need to tweak the interest rate to match how regularly she's making her contributions. So if she was making them semi-annually, then we'd have to calculate the effective interest rate for compounding semi-annually, and then anyway, so after making the last payment at the end of the 10th year, she stops making any payments due to financial difficulty. She leaves the money in the account until the end of the investment period. Calculate the value of the investment at the end of the 16-year period. So let's put all of this information onto a timeline. So at T0 she puts in 800 rand. This is also different to your stock standard future value. So your future value formula assumes you start making your contributions 1 month later, right? So we just have to be careful. We just have to consider that there is an 800 rand that she starts with. We just need to factor that in. And then month 1 she adds another 800, month 2 she adds another 800, and so on. And then it says that at the end of the 10th year, so that is now month 120, at the end of month 120, that is wait a minute, at the end of the 10th year she stops making any payments. So that makes me feel like it's actually T119. These things always get to me with financial maths. Oh my gosh. Because at the end of the 10th year she stops making any payments. So that would tell me that the last month, at the end of the 10th year, the last month of the 10th year, she did not make any payments. Oh, that's tricky. The English is dribbling me, and I'm pretty sure that if I get this question wrong, it's because of this decision. But anyway, so from then on, no more contributions. So T120 is empty, T121 is empty, and so it goes. And then at the end of the 16th year, we want to know how much she has. 16th year, 12 months, so that's T192. Right. And all this while, we have an interest rate of 9% per annum, compounded monthly. Right. So the normal future value formula is, let's see if I remember this. I think that is what it is, right? But now, because we're dealing with a case where there's an extra payment at the beginning, that means that it's not going to be n payments, it's going to be n plus 1. So That would be the amendment there. So always look out for the English. Right, so in this case, we are specifically talking about the value of the investment over here, right, when she makes her last payment. So that would be at T 119. Okay, so we put our values in. So that would be 1 plus 0,09 over 12. And at this point, it's 119 plus 1 payments. So it's 120 minus 1. And then down here, we have 0,09 over 12. Right, so then we put that into our calculators. So that is about 154,811,42 blah blah blah. Right, so that is the value of the investment over here. Then she keeps that money for the rest of the time. So that is how many months now? So this is 1 month, 2 months. So 192 minus 119 is 73 months. 73. Yes, I think that's right. So right, so now we just use our good old compound interest formula, where the primary blah blah, the principal amount is this guy that we just worked out, and then the interest rate is still 9% compounded annually, and now we said that that would be for 73 months. So let's calculate that. Yo, I'm so nervous. I'm so nervous, I won't even lie. Okay. 1 plus 0.0 died. So that ends up being about 267,111 Rand and 14 cents. Let's see what the memo has to say. Ooh. The memo. Oh, we have differed. Okay, so for the first question, the memo agrees with me. We are believing in this 29,000 mission. That is true. Okay, so for the second one, like I told you, I already see where I went wrong, so I'm just gonna go ahead and correct that. So annoying. So I don't even know what is the remedy to these things. I don't think you would lose a lot of marks for misinterpreting the way that I did. I don't even know actually, like, if in the exam you can ask the clarifying question to say, did she make a payment at the end of the 10th year? So only from the 11th year onwards she did not resume payments, or was her final payment the second last month of the 10th year? Because for me, I feel like it's a valid interpretation of this. After, oh, oops. Never mind, never mind. I've just seen this. I was about to reread it, and maybe rereading is a good tip. After making the last payment at the end of the 10th year. So she did make this payment over here was made. Oh, the agony. Okay, let's do our corrections in pink. So this payment was made because it says so, literally in black and white. And honestly, I was thinking to myself that these questions are usually so good about being very clear about which payments are included, which ones aren't. Anyway, right. So we want to find the value of the annuity at T120. This is after she's made that last payment. So then it's not just the 120 payments that have been made. Remember that there's also that initial one that was made. So this would be 121 payments. And so if we work that out, and down here, so this actually ends up being 156,772. Whoa, what is happening? Okay, comma 50 blah blah blah, and then we put that guy in here to see how he grew for the rest of the time, and it would now be for 72 months, not 73. Okay, right, and that gives us the correct answer of 268,481,18. So close, so close. But yes, going forward, I will not avoid finance questions as much as I used to, because these formulae are really, really handy as long as you remember the rules, the conditions for which they work, and how to tweak them when the conditions are not conditioning. Right, I hope that that was a valuable exercise, mistakes and all, and let's catch up another time.